Hey everybody, this is Mark Vogt with Topics for Consultants. Kind of the opposite of Topics for Dummies, where you water it all down. Consultants typically have 24 hours to become an expert in something. So this is part of a multi-step series, giving people insights, quick insights on key technologies that are out there. And what we're going to talk about today are Git and Github.com. We're going to go over key concepts, general usage. It's just a quick tutorial, the key points. Git is a source control management tool. It's a repository tool. Initially, it distinguishes itself from other version control systems by being decentralized, where other technologies have one central repository. Everybody goes and checks out code, works on it, checks it back in, but then there's always people stepping over the top of each other. Branching and merging tends to be a bit problematic. The distributed versioning system or distributed repository system developed by Linus Torvald, the creator of Linux, is distributed in nature. The whole idea is everybody's got their own local repos sitting on their laptops. So they create local repos into which they're going to create one or more directories. Each directory is a software development project inside that local repo. If we had someone like Mark working on a particular project, he's writing a file, he's actually committing to that local repo. Raj, somewhere else, maybe on the other side of the planet, is working on his projects. He's also working inside a local repository. But when the two of these people want to start sharing, GitHub.com comes to the rescue. It provides a centralized mechanism, a centralized source for repositories in a world where typically it's a decentralized, distributed set of repositories. How does it all work? Let's go through the motions of how Mark and Raj would actually work together on a project. Let's say Raj had used his GitHub account up in github.com to create a Raj/project A directory. A repository, we'll call it a cloud repository, to differentiate it from a local repository that lives down on his laptop. And it's important to understand that there are two types of repos. There's the cloud one that you're using to share with other people. Think of it as a master. I just simply call it what it is. It's the cloud repo. It's a repository up in github.com. Raj created an empty one in github.com. He cloned that repository down onto his local drive. That's that process of bringing a copy of this cloud repository and making it available on your local machine is called cloning. So he actually defined his own empty project. Maybe it had a README file, that's another topic. Then he cloned it down so that it lives in, let's say, C:\dev/project A. Raj begins to work on files, continually making new files, changing the files that are there. The act of actually interacting with some kind of an IDE, like Visual Studio Code, etc. The act of interacting with that IDE, he's actually saving files back and forth, and this is what is called committing. So you're cloning an original cloud-based repository, you're working on your individual files, adding new files to that project, changing the files that are there. Each time you do a save, that's called a commit. You are literally interacting with this repo. And from the moment you started to change the files that are in that local repository, it's actually going out of sync with its counterpart up in the cloud, with its counterpart cloud repository. So that what's needed next is that on a regular basis, Raj is going to do something called a push. He's going to take the current contents of this local repository and he is going to push all of that code up into the cloud repository, synchronizing the two from down to up, so that now these two repositories are completely in sync. He closes this down, goes away. He might come back and just as a precaution the next day, he's actually going to go and get the latest copy that's here. There's no reason to think that it changed at all, but he might actually bring another copy down. To bring down another copy, this is what is called a pull. He's pulling down a copy. And that makes sure that whatever he's working on locally is an absolute duplicate of what's already up inside his cloud repository. So we built a project. We created a project first up in GitHub. We cloned it to make a local repository. We used some kind of an IDE to actually make changes to that local repository. Each time we were committing those changes to this local repository. When it was ready to be pushed back up into the cloud, we did a push, and the very next day, just as a precaution, because some people might have access to this repo as well, we do one final pull. Step 5, we're cloning, we're committing, changing and committing, we're pushing, and we're pulling things back down. These are things you're doing on a daily basis in your own repository. Raj now wants to make this entire project A available to Mark. He could send it to Mark quite all right, but the easier way is this. Over here, Mark is going to go up into his own GitHub account. So now we've got Raj over here. Over here we've got Mark's account, and Mark is actually going to go, he can browse into Raj's project, and he can do something that we are going to call, he's going to make his own clone, of his own copy of that repository here, and this is called forking. When Mark forks, he ends up with a Mark/project A. It is an exact duplicate of Raj's. They're even linked. They're linked in one way that if Raj ever wanted to go and get stuff out of Mark's repository, he could merge changes back into his own repository. But for right now, for this discussion, Mark now has an exact clone of Raj's project A, a copy of that repository, but Mark works down here. He needs to get this project down here, and what we saw in our initial part of our discussion is that what Mark needs to do is actually clone his new cloud instance of that repository. He needs to clone that locally down here so that now Mark has a C:\dev/project A. Mark will continue to use his IDE now to interact with files. He's going to add stuff to this project, changing. All of the changes that he finally makes, he is going to commit, and in this case, he's committing to his own local repository. This one potentially looks nothing like Raj's. It looks nothing like the cloud version, it looks nothing like the local version once Mark starts changing it. When Mark commits those changes locally, now he wants to try to merge those changes. He wants those changes back up inside the cloud. Mark is going to do something called a push. And now Mark has all of the all of the changes that he made locally now exist up inside his cloned, up inside his cloud repository of Project A. And if he wanted to donate those changes to Raj's, the very last step in this scenario is that Mark can actually do something called a pull request, where he can send a request off to Raj saying, Raj, I've got some stuff in my instance, my copy of your cloud repository that you may want to incorporate inside your repository. Raj can then actually look at all of Mark's changes, and he can actually perform what is called a pull followed by a merge. So that what Raj started off making empty, way down over here, he had an empty repository, he cloned it down to his local repository, he began to change that local repository, he committed those changes locally, he pushed those changes into his cloud and can continue pulling, changing, committing, pulling, changing, committing as much as he wanted. But at the same time, what Mark did was bring those changes, bring his own copy down, clone it, make changes locally to his own local repository, his local copy of that forked instance or that forked repository from Raj, Mark then makes changes locally, pushes changes to his cloud repository, and now we end up with two repositories here, local and remote, that used to be copies of Raj's over here, but now they're not. But Mark might actually have changes in that code base, in that project, that Raj wants. Mark can then send a pull request over. It's a courtesy. It's not a demand, it's just a courtesy. Raj could look at the nature of Mark's changes on it whenever it is convenient for him, and then actually do a merge of those code changes into Raj's major code base. That's the cool part about all of this GitHub working together with Git locally, and the idea that there are distributed repositories. You'll notice nowhere in here did I actually talk about checking in or checking out code. It disappears. You go and you work on code locally, you commit those changes, and it creates a version trail constantly. There is no need to check in and check out. You're the only one working in this repository. Every individual person has their own repository, their own copy, their own local clone of what exists up in the cloud. And all you need to do is actually submit changes to, or push changes into your cloud repository, and then submit these pull requests, and it gives this codemeister, or the person that owns the original body of code, an option to go in and selectively pull and push, or to pull and to merge your changes into their code base. That is the most common scenario played out in this idea of social development. That covers the basic of using Git locally, GitHub up in the cloud to actually create various kinds of repositories that you can then work in, synchronize, and share with other people. In upcoming episodes, we're going to talk about another common scenario of using GitHub in a distributed repository, which is the idea of creating branches, that you branch your code on a daily basis, multiple times a day. This is a very rare thing in the world of centralized repositories, but in the world of distributed repositories in Git, you do this all day, every day. You create feature branches and fix branches and main branches and version branches. You're constantly spinning up a branch to go and perform something that's experimental in nature, and if you like the changes, you merge them back into the code base. If you don't like the changes, you throw it away. And your original code base has been completely pristine. That is a powerful topic that we're going to cover in our next episode. Thanks. Talk to you guys soon. It was great. This is Mark Vogt with Topics for Consultants. Hope you enjoyed this. Please subscribe to my channel. Let me know where you want to go with this. Bye.